Let's talk about simultaneity. Simultaneity. So a thought experiment was proposed. A thought experiment, sometimes called a Gedanken experiment, or probably properly pronounced Gedenken, but I could be off on that. So we have somebody standing over here, and I'm just going to go with the names from my original notes. So I have Ryan here, standing by train tracks. These are train tracks. I have a boxcar right here that is zipping by at some speed v. Now, on top of the car, I have Peggy. Now, when the car is lined up so this is my Ryan right here, when the middle of the car is perfectly lined up, there are going to be two flashes of light that get sent off. You can think of this as an explosion on each end. We have a detector right here. And so this flash of light, these flashes of light going in all directions. So the thought experiment is, this is the right and left side. So if the right light, so represented by the R, if the right light hits the detector before the left light, then this will glow green. If the left hits first, or left and right hit at the same time, then this will glow red. So the thought experiment is, well, from Ryan's point of view, it gets to this point that both flashes go off. So from Ryan's point of view, because the light on the left is traveling in the direction that the train is traveling, it has farther to go. And the light on the right doesn't have to travel as far because this light goes off and this is heading towards it. So from Ryan's point of view, when these two things go off at the same time, the right light should hit first, and therefore the detector should glow green. From Peggy's point of view, if the right and left light go off at the same time, well, the left and right sides and the detector are all not moving from Peggy's point of view, therefore the two lights should hit there at the same time, and therefore they'll hit at the same time, and therefore the detector will glow red. So if you run this thought experiment, the central light, and then you stop the train, this will be either red or it will be green. It can't be both. And so only one of these actually is actually going to happen. I give you a moment to think about that. Pause the video if you need to. I'm just going to take a breath, and then we will come back. All right. So one thing I will establish is that from Ryan's point of view, he sees these things go off at exactly the same time. And I'm not talking about some subtleties here. Ryan is perfectly capable of detecting things down to the nanosecond or smaller. So Ryan sees these two things go off at the exact same time. So if we look at from the train point of view, we have the train at this point right here. Left and right go off. So then I have light traveling in both directions. The train, meanwhile, is moving to the right. And so the train is now here. And then 1 moment later, this light is now traveled out to here. This light has traveled out to here, and the train has traveled out to here. So the train is moving to the right, and the light is just traveling towards each other. So this is what's going on right here. The question is, why does Peggy see something different? Because the light actually will glow green. But since none of this is moving from Peggy's point of view, why is it not going red? What's wrong with it? Well, the only way that this can happen where these things, Ryan says they go off at the exact same time, and Ryan is correct, is if they don't go off at the same time according to Peggy. And that is the difference. Since neither of these are moving from Peggy's point of view, what Peggy's going to happen for Peggy, so this is Ryan's point of view. From Peggy's point of view, right will go off. And so that light is traveling outwards. Here's the detector. And then left goes off. And so right, it goes off before left does. And the question is, can we actually come up with math to back this up? And yes, we can. Oh, I'm not quite sure how to do my thumb, so it looks like it. All right, perhaps I'll edit that out. So just because things happen simultaneously in one reference frame does not mean they happen simultaneously in another. Now, I do want to eliminate one thing here, that if I have, let's say I have a tree here, and I have lightning strike it, and then I have Ryan and Peggy both observing it. Ryan will see the flash of light before, or see the tree get hit before Peggy does, because light does take time to travel. However, this is not what we're talking about with the simultaneity. This is a different situation here. This is because they can both go back, and if they calculated, oh, I'm this far away from the tree, I know light travels at such and such a speed, therefore I know the time and when the tree got hit. They would both do the calculations, they'd get the exact same time that it gets hit. So we're not talking about simultaneous observation, we're talking about simultaneous events. Things do not always happen in the exact same time in one frame as it does in another. And so that will be the subject for another video.